Did any of you hear the phrase, the recording have started? I think it's recording. That's kind of also important. Yes, it's recording. So when you click the grade test button, it shows you what will be red and what will be green. And you write down, because that information will disappear, you'll write down which questions are incorrect. From this point, we do not click preview or enter. You just finish answering the test, click grade test, and that will be the end. The most obvious one, you do not click back button, like it doesn't like the go back button. Don't do that. And do not log out, obviously, or else everything goes down the drain if you do that. While taking a test, you're not supposed to leave WebWork, open another tab, and so on. The system is pretty clever. The moment you open WebWork on any other device or even in any other tab, it will notice that. And then we're going to have proofs. We're going to send them to students as we did last semester. It's super upsetting. You get 0 for everything. You might not even notice. It's not going to tell you you're cheating. It will just stay quiet and then log you out. So the most important is this. Let me try to do it again. So as a student, I go to homework sets, and now I see there's a practice test. Here it is. And I'm going to take it. The password I put 123. No. And then I'll put some answers, something not correct to see how it works. And then 16 correct to see how it works. I definitely going to do preview test. So it records. It doesn't say anything about grading it. Then I will do a graded test. And it tells me which one is correct and which one is incorrect. And it doesn't tell me what is the correct answer. I'll take a pencil, I'll write down, it was problem 1A. And then I continue working on it. And then you click grade test and test is submitted. See, that's it. When you click it second time, you only can click it once. So it's an opportunity to see your answers once, not to see the incorrect problems once. So out of 65 problems, you don't have 65, you have 12. You will see what are going to be green and red. Go back, fix the red. If you can, click second time and you're done. That's kind of the idea. And again, don't browse anything, log out, WebWork from all the devices, and put your phone away. You only needed to push your login, and that's it. Does that make sense? Well, last chance to ask questions about this inconvenience, but it is a good thing though. So they just did it once a couple of years ago for you to have a second attempt, but then that cost so many questions because students were so confused and they were upset when it did not work. So that's the most important. It's a very good question asked in the forum. Do we have 2 chances to answer the questions? Yes, you have 2 chances to answer the question during 2 hours timer. So this timer will keep going. And once you submit the whole test, you're done. So that if that makes sense, you cannot have a second attempt for the whole test. Yeah, that's kind of exactly how you said it. Okay, very good. Let's do our review. Starting with vectors. Check it out. Okay, good. Good job for coming. I definitely prepare really good exam reviews because I don't want to waste your time. I know people are very busy. This class is very short. So would you rather do talk right now or listen to this review? The review better be good, or else it's a huge waste of time. So I put some information, lots of effort to put in good review. But the only issue is I'm not an evening teacher and people always want to meet in the evenings. So keep an eye on, if I say something wrong, let me know. Don't be afraid to say that. I will not see your chat right now. I'll be checking it from time to time. So accumulate some questions and I will check, or unmute yourself. Thank you. I usually have 2 computers. It's easier this way, but not today. So vectors, most questions in the test will be about vectors, have both directions and magnitude. That is the whole idea. That's for the first time we introduce something that has a direction. I will just briefly gonna go through definitions. You can always review the video and pause and read that. But basically we have addition, subtraction of two vectors. You've seen those graphs. This is how it looks like. The vector called position vector, if it literally pointing at the position P. So position means point. And if there's a fly over here, the position vector points at the fly. That's kind of the whole idea. And the fly will have a coordinate. The fly is located in the 3D coordinate, ABC. So the vector, and we know how the vector is created, second point, A, B, C, minus the original point, right? That gives you the vector, position vector. Components of the vector code ABC. The most important is the size of the vector code, magnitude. It's the square root, and then square each component add together. So if you read Wikipedia, people in the world did not agree to have it with 1 bar or second double bar. Double bar is more professional, but Wikipedia actually says that somehow people did not agree on that. This usually reserved for the absolute value. That's why this one is more preferred. But in this class, I can see in the book, they switch between those two. And also notation of the vector, most of the time it should be a little vector thingy on the top. The lazy one is just the bar, but it should be something. And one more way is to make it bold when you type it. It was so hard for people to figure out this thing before computers. So they just decided to use bold font, like in this book. See, it's just bold. So people know that it is a vector. If you was curious, that was my V. Cursive. Unit vector. You will be asked to find unit vector, so I already have prepared some stuff. All the points, the unit vectors. But basically, here's the vector. For example, it's a wind, right? And as a scientist, at this moment, I don't care how strong the wind. I just want to know where is it going. Where is it going? Thus, I don't need its strength. I only need the direction. And direction will be just size 1. So the strength of the vector should be 1. The strength means magnitude. Thus, I want to get rid of that magnitude. And that's why I'm dividing by it. That's kind of the whole point here, is to get rid of the size of the vector, to make it unit. They also call it unitization. Unitary and unit, all those words are everywhere in science, physics, chemistry, math, of course, engineering. So if I just want to see where stuff is going, where does this wind heading, then I divide by its size and call the unit vector. So it's the original vector divided by length, which means the direction will stay, but the length will shrink to 1. That's called a unit vector. Before we go to standard unit vectors, you are required to know for the test those things like, can you find A plus B, A minus B, right? 7 times A. Can you do these operations? I mean, for now, this is just algebra. So you practice it once, like a week ago, and you should be able to be good at this. Something like minus 3A plus 5B. So basically this accumulates all the knowledge. Multiply by minus 3, multiply by 5, add together. And finally, find the magnitude of the vector, right? So all of those are vector. So that is the idea. I will not show that. It's lots of writing, and it feels like you can do it quickly just by looking at it. This is not something too complicated. What is, I think, was complicated for many of you is find the, so example 1. Find, you make it. Find the unit vector. You're like, oh, that's easy. I know it's vector divided by its size that have the same direction as vector A. A is 1, let's do minus 2, 3. And length 4, So what is going on here? The classical small examples, we usually put them as multiple choice for the in-person classes. For the online classes, I see they gave me the exam. I don't see any multiple choice there for now. I think in the final exam, there might be some. Solution, do you know how to do this one? So steps for unit vector are always the same. Unit vector, you know what to do. You find the size of A and get rid of it. The size of A is the square root of 1 plus 4 plus 9. You see negative sign? I completely ignore it because everything is squared anyways. So it's going to be 14, square root of 14. Don't simplify anything, just type it as square root of 14. Don't make algebra mistakes. Then, so step 1. Step 2, you have A over A. I always say it A over A, but it means vector over its size. Vector is -1, -2, and 3 divided by square root of 14. How do you do that? You do component by component. Equals -1 over square root of 14, -2 over square root of 14, and 3 over square root of 14. That should be the answer if they did not put the last sentence at the end. That is a nice unit vector A. They also called U in the book, but it's just unit vector. It doesn't have to be U. So what happens with this length 4? Just multiply by 4. Basically, we made length 1, right? So guess what should you do to make it 4 times bigger? You multiply by 4. So it's going to be 4 times A over size of A, like so. And the answer is here. Whatever I just had multiplied by 4. So -4 over square root of 14 minus 8 over square root of 14. 4 times 3, 12 square root of 14. And it's a vector. So you see, it's a unit. It was unit. Then we multiply by 4. So now it has length 4. But it has the same direction as A. Because of this little diagram I showed you. Unit U has the same direction as the whole thing A. We're just shrinking A. That is my idea. Does it make sense? Let me check the chat. There's something in the chat. This review will have more stuff. That's kind of the whole point. I did not want to repeat the previous review. I just want to, this review is different. There was a question in the chat. Is this review the same we already have? No, it's different. So have that. From here, we also introduced you 3 amazing standard unit vectors. They're super famous. So like the whole world is learning them. It's kind of phenomenal to think about it, that you're learning this, students in Japan learning this, Croatia, and I always like to say even in Canada, they all learn these 3 vectors, I, J, K, 1, 0, 0, 0, 1, 0, 0, 1. As you can see, they have size 1, but they are special. They're not just like random pointing somewhere. They're pointing to the axis, towards X, towards Y, towards Z. So basically, they tell you those specific orthogonal directions. If the wind is going towards me, that's X direction. How much is going towards me, and so on. So I, J, K. And then the theory in the whole idea says that each vector can be described as I, J, K. So here's vector R pointing at P, like we had before. And R, as always, was a vector A, B, C. So point was A, B, C. Remember the difference. P is the point, no bar, parentheses. R is the vector A, B, C, bar and braces. That's a vector, right? But the whole cool point is now you can write down in a new form, which called unit basis vector form. R is now I, J, K. So it's going to be A times I, and I is a vector, plus B times J, and J is a vector, plus C times K, and K is the vector. They mean the same thing. So you will be given the same information in both forms, and you need to be comfortable between those two. So that's why I wanted to cover this, because you will have stuff in both. Before we go to dot product, it's actually a bit too early. I want to cover some more stuff. So I wanted to improve these notes a little bit. So let me go here. What I also wanted to show is we have projections, not the scalar in those projections yet, but if I give you a point P and it has 1, 2, 3 classical number, can you find projections? So you need to be good in imagining what is happening in 3D. And you're like, I'm not really good in that. Yeah, but that's kind of multivariable calculus. So I don't think you have a choice. The whole point is to teach you that. Is to teach you to go out to the third dimension. And then literally after this exam, next exam and third exam, we go into upper dimensions, 4 dimensions, 5th dimension, and so on. So you have to be good. Projection of P to X, Y, Y, Z, X, Z. So do you understand what is happening? We have a 3 dimensions right now, X towards me, Y left and right, up and down, Z, right? And then there's a P, so imagine it's flying, right? Again, flying, and has 1, 2, 3 classical example. Do you know what's the projection of that point on the plane X, Y? Either you imagining it, it's on the floor. So whatever the floor, that's X, Y. And then you actually see, so, okay, like, oh, so what is going to be? First of all, the projection is the point. So it's going to have 3 coordinates, not a vector, a point. They're asking you, what is the coordinates of this point? The projection on X, Y. Well, 1 and 2 stays the same because this is the vector R pointing at P. But this is the vector, say, R sub 0, pointing at projection of P on XY plane. So it doesn't have a height. It's like the fly, you kill the fly and falls on the floor, right? Now it's on the floor. Very sad. So the trajectory, the coordinates is the same, except the last coordinate is 0. And then the trick is whatever is missing, that is a 0 coordinate. Whatever letter is missing, even in 5 dimensions, it's the same thing. The projection to XYZK plane will be whatever is the missing coordinate is 0. So 0 for the Z, 0 for the X, and 0 for the Y. And that's how you do. 1, 2, 2, 3, 1, 3. That's how you do it. Fast, and it's pretty clear. It's, if you imagine, it's exactly what it is. Make sense? Checking the chat. Chat is good. Okay, good. Also, when we learn about dot product, oh, we didn't learn yet. So we're getting to dot product right now. I'm gonna go back here. Dot product. This one is the favorite one. Usually students like it because you just do component by component product. So A and B multiply, add, A and B multiply, add, A and B. So it's called product of corresponding components, and then you sum up all the results. And then from there, we have some formulas. So what is the formula for the angle? Theta can be found as arc cosine or cosine minus 1 of dot product A and B, size of A, size of B in the denominator. It's coming from this formula. Usually students remember cosine of theta. That's easier to remember. AB over AB, that's how people remember it. And then you just remember that you divide by the size of it. It's too big. And then to find theta, you find arc cosine or cosine minus 1. So on a test, we might ask you to find the angle with a given 2 vectors. That's important. Also, do you understand the difference of U times V versus U times V, where U and V are magnitudes? Let's practice that. Here, example 2. if A is 1, 2, 3, and B is 0, 1, 4, then A times B dot product dot. So you see, I was always trying to fix students in calculus 1 and 2. Many American students have a bad habit to put little cross between in the product. That comes from the school. Some teacher taught you this and now you're doing it forever. So it's actually wrong. Now you know there's a special notation for each, for everything. So there's like a cross in this circle, for example. That has a meaning. Dot has a meaning. Cross has a meaning. All of this has a meaning and you're not supposed to just use it for fun if you plan to stay in STEM. Okay, so dot product is going to be, also very interesting. We always give it as a multiple choice. Is it going to be a vector or is it going to be a number? So if it's a vector, we're going to have 0, multiply corresponding components. 2 times 1, 2, 3 times 4, 12. That's one of the answers. Is that correct? No. So remember, the result of a dot product is a number. That's why in Europe we call it scalar product. That's why I don't remember learning it as a dot product. I was actually surprised to see that name when I was teaching it here. In Europe we call it scalar product, which literally gives me the answer. It should be a number. Scalar is a number. The number is 1 times 0, 0, plus 2 times 1 is 2, plus 3 times 4 is 12. The number is 14. That's A times B. But what is A dot B? What is that? That is a normal product we know from numbers. Square root times square root. So that matches that product we know from before. You find the size of each, which is going to be 1, 2, 3. So that's going to be 1 plus 4 plus 9, 0 plus 1 plus 16, and multiply those two numbers. Make sense? So make sure you understand the difference. Checking. Good. Okay. Before the orthogonal stuff, I want to show you that A times A is A squared. That's exactly like it matches with the algebra. 2 times 2 is 2 squared. But now we're talking about vectors, right? So it's not the same thing. But in the dot product, it is. Dot product, and you can check, gives you the size squared. Now, what does it have to do with perpendicularity? Perpendicularity. Do you know how to say perpendicular in the Russian? Perpendicularny. So, if dot product is 0, that means vectors are perpendicular, and vice versa. That's why it says if and only if. If vectors are perpendicular, you will calculate dot product, it will be 0. There's no other choice. So I like to explain, maybe if you watch my videos, you know, in class I explain it this way. Dot product shows how parallel vectors are. Vectors are. So if they are very parallel, what does it even mean to be very parallel? So parallel vectors looks like this. We know that from school. Then it's going to be a big number. But then, you know, this vector and this vector are almost parallel. Can we describe somehow what does it mean to be almost parallel? Yeah, that's why dot product was created. Dot product tells you how parallel or not parallel things are. So if two vectors are almost parallel, just a little bit tilted, the number will be big. Remember, it gives you scalar, right? Then if, say, the vector is getting a little bit less than parallel to the second vector, the number is getting smaller, smaller, and as you guessed, not what does it mean to be not parallel at all? That means to be perpendicular. The number is 0. And then again, it becomes bigger, 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 very parallel. So these two vectors are parallel. The number will be the biggest. That's like a very genius idea. I feel like it's pretty cool that in engineering, how would you describe when you build a building, two walls that are almost parallel through the dot product? So that's why the angle has connection to the formula. And that is why if they are not parallel, guess what? They're perpendicular. So the dot product will show you 0, the smallest number. So how do you know that the two vectors are perpendicular? You calculate the dot product. If it's 0, good job, they're perpendicular. You can do that. Okay, before cross product, one more thing we learned from this is projections. The hard ones, projections, the two formulas. The first formula we figure out vector projection, which is projection A onto B. That's called vector projection. Actually, this notation, proj, is not international notation, and we have different notation for that in the world, but it's fine. The formula is the same though. So it's hard to remember. That's why, let's see. I think it's projection B onto A. Yeah, that's B onto A. So my friend told me this is how he teaches that. I kind of liked it. It's kind of cute. B projects onto A. So A and B starting relationship where A really likes itself. So it's squaring itself. That gives you a number. But then to become a vector, it's multiplied by A. I actually don't remember how he mentioned it. He mentioned that the B wants to be A so much it hugs A at the end. Oh yeah, that's what he said. Anyway, this formula was hard to remember. I definitely understand that. And then this is the vector projection, which basically can be illustrated like so. The vector A doing nothing, just chilling. The vector B decides to figure out how much B is onto A. The question can be rephrased is how much shade B gives onto A. So again, engineers like, what is the shade of the parking lot from, for example, from the roof and stuff? This is what it is. If you want to find the vector shade, that's a vector projection. That means it has not just size, but also direction, right? So how much shade B gives you? If B is very parallel, the shade is big. If B is perpendicular, do you know what happens? The shade is 0. That's why it has connection with dot product. But sometimes, especially in engineering, we just want to know how big the shade is, and we don't need a vector. That's comp or scalar projection. A times B divided by A. So we don't multiply the end by A. Let me see people saying in the chat. The magnitude is not squared, right? I'm kind of was thinking about it too. So yes, and the magnitude isn't squared. I was thinking about it too. Is it squared or not? I suddenly hesitated. And then if you don't multiply by A, it ends up to be a number because A times B is a scalar and divided by a number, it's a number. So that's just the size of it. If we want to know how long is the shade is without any direction. Practice that because it's kind of also shows up sometimes in the final exam anyways. Okay, cross product. We're slowly going through my list, which is very good. Let's check again. Okay, good job for the chat. Cross product answers the opposite question from what I just said. It answers how perpendicular, this is sign for perpendicular vectors are. Vectors. So completely the opposite from the dot product. That means the bigger this number, the more perpendicular vectors are. That means if vectors are parallel, guess what? Completely parallel, right? The cross product will be 0. So it reverses the whole property. But calculation is different. because now it's a vector. And that's why I don't remember the name cross-vector product when I was teaching this. I learned it as a vector product. So there's a scalar product and vector product, which literally gives away in the name what is doing, which one is which. So the answer here is a vector. And the cool thing is, because it's about perpendicularity, this vector perpendicular to both A and B. Idea, here's A, here's B. Let's find the vector perpendicular to both. Here it is, A times B. The cross product perpendicular to both. So as I told you, it is the biggest when it's the most perpendicular, right? So it's always perpendicular. Two vectors can be perpendicular to each other or not. So that matters. But if and B, A and B are parallel, so it's going to be like this, the cross product will give you 0. So that's how you can also check, but it's like a very long calculational check for vectors to be parallel. But again, it's reversing the idea of the previous dot product. A times A is 0. Guess why? Because A parallel to itself. A and A, you know. If you want to reverse it, change the sign. I, J, K give each other because they're all perpendicular to each other. So one of them, I, J, K, is always a cross product of two others. There's one more angle formula showed up. I don't put this angular formula on a test. Usually people don't remember the angle formula for cross product. The previous one is more popular. So usually students use that one. Actually, usually scientists use that one. But there is a new form. Okay, that's the review. First of all, you need to know how to calculate A and B. There'll be so many questions about cross product on the test. I saw that. So just letting you know, you need to be really good at this. If you're gonna calculate A times B, you're screwed. Like you will not pass the test. There's just too many times they're asking about it. So let's practice a couple of times. There's so many questions corresponding to this. Let me see. Product, find the angle between, blah, blah, blah. We know that. Yeah. So a couple of times we're going to ask you to find one of the three things or all of them. Area of the parallelogram, area of the triangle, and volume of parallelepiped. Like to make fun of it. So let's see. Area of the triangle that has points A, B, C. I have a nice screenshot. I took some screenshots from your homework. Yeah. I should stop writing in red. Becomes too aggressive. -2 and 2 and 5. That's from your homework. R 1, 4, and 4. S -2, 4, 1. Like so. Find the area of the triangle and they give you 3 points. Or find the area of the parallelogram, like over here. I thought it's going to be here. Okay, fine. Then they give you 1 more point. The area of the triangle will be, let's just solve it. Solution. You imagine 3 points. Here they are. R, okay, Q, R, S. You need, if you have more points, that creates parallelogram, then you choose any 3. That's the idea. Doesn't matter. The beginning is the same. You choose any 3, and then you choose the centerpiece. So whoever will be the beginning, say Q is the beginning, then find QR and find QS first. The answer will be the same. Area is area. So that's like a fixed number. It's going to be the same. So just be careful with calculations and it will work out. If you choose Q to be the centerpiece, then you need to find QR and QS. Do you remember how to do it? Next minus previous one, R minus Q. So let's go with A. That's going to be QR. Notation of the vector, by the way, is QR and then the connection between those 2 letters. QR is 1 minus -2 that's 3, 4 minus 2, that's 2, and then 4 minus 5, that's minus 1. Yay. And it's not parentheses, it's actually a vector. So be careful with notation. Find B, that's going to be QS. Same idea. Next minus previous one. So the nose minus the tail. B is 0, minus 2, minus 2. 2 and minus 4. Good. We have that. And now let's actually perform at least once the whole beautiful idea of the cross product. So if you find right now cross product and take a size of it, that's going to be the area of the parallelogram. And the triangle is the half of that. But the steps are the same. Step 1, create 2 vectors, choose 3 points, create 2 vectors. They should start from the same point. So that's important. Because then step 2, visually, this is what I'm doing right now. I'm finding from this point I chose to be the tail, the beginning, the sticking out A cross B, a perpendicular vector. That's a cross product. A times B is, very quickly, I, J, K, or in order 3, 2, minus 1, 0, 2, minus 4, like so. Set it up, start writing it down. So I goes first, and it's a vector. Then I imagining it, I teach it several ways, but the way it's fun to teach is there's a bomb happening at I. The bomb destroys everything in the row and everything in the column. So whatever is left, you do cross product. 2 times minus 4 minus 2 and minus 1. That is because the determinant of the 2 by 2 matrix, just put this, the determinant of A, B, C, D matrix is AD cross product minus cross product minus CP. So because we know that, we implementing it is this for the 3 by 3 matrix, determinant of the matrix. So it's going to be minus 2 and minus 4 is going to be minus 8 minus, don't forget that, 2 and minus 1 is negative 2. So be very careful with those things. Now, plus J, let me ask you to find, so you're going to do the same with J. Let me ask you to find a mistake. Plus K. Do you see the mistake? Move this. Doesn't fit. While I'm relocating things, do you know the mistake? That's a very important mistake not to make. Let me check. Someone did. Negative. Good job. So the second variable should be negative minus J. That comes from the way we build determinants. The 3 by 3 matrix is plus minus plus at the top. And then actually just keep changing forever. A minus, so it should not repeat plus, minus, plus like that. But because we only use, I mean, you can use any, but because we usually use the top, it's supposed to be plus, minus, plus. So the second one is always negative. At least it has negative sign in front of it. Then the same idea was bombing. So J is like a computer game, bombs the whole column and the whole row. And you repeat the cross product 3 times minus 4 is minus 12. Minus 0 times something is 0. I always don't care about that, which is 0. If I see 0, that's 0. It's super nice. Have zeros. And then the last bomb destroys the whole column and the whole row. 3 times 2 is 6. And then I don't care about the last part because it's 0. So do that. And also before you submit the test, you should check your calculations. I would go back without looking. Usually what I do as what I did as a student, I would go back and I would not look at my answer. And I would redo the whole thing. Only if you redo it from scratch, you can catch the mistake. If you try to find the mistake, you will usually don't find it. So minus 8 and plus 2 is minus 6. Let me write down the answer. It's going to be, you can write down either in the form IJK, minus 6i, and then plus 12j and plus 6k, or you can write it down as minus 6, 12, and 6. You have to be very comfortable with both notations. So step 3, if you find the size of this vector, minus 6, 12, and 6, that will give you area of the parallelogram. So the size of the vector, which is magnitude, is a square root. 6 squared plus 12 squared plus 6 squared gives you 216. That is area of the parallelogram. Do you know how to say parallelogram in Russian? Parallelogram. But triangle is half of the parallelogram. Do you want to prove? Here it is. See, it's voila, it's a half of the parallelogram. So if you want a triangle, you just divide by 2. Don't forget about doing that. 4 triangle will give you square root of 216 over 2. And just type this in. Don't simplify anything. This is good enough. Very good. And for you to know, there's also volume. So here it is. There's a property. Area of the parallelogram is the magnitude of the cross product AB divided by 2. But did you know? Did you know that also there's a volume? Let me put it in the red. I did not put the volume on the test. Of volume of the parallelepiped. So we go into 3D. Parallelepiped. That one is A times B cross C. Look at this cool formula. Volume. So that makes sense from the area. If we add one more dimension, like this, like, okay. I draw it usually like this, connect, right? Parallelepiped. So the volume is the upper dimension. So we just multiply this sticking out vector by one more vector, gives you number. Very cool idea, Jen. So all of this is connected. Nice, no questions, that's good.
Hi.
Yes.
So can you take the cross product instead of like just all 3 where it's like instead of ijk on top, it's just a
ijk on top.
like
Oh, this is
replacing it so it's
so you just want to like not write this down basically?
Yeah, but for the volume of the yeah, the other one, can't you just do A, B, and C as like the cross product?
That's an interesting point, but there is that's a cool question. So the question is, let me answer. It's like this: A, B, C. So number. The thing is, the result of the cross product is the vector. So you will get. Oh, actually, that's not true. Yeah, you're right. The numbers will be multiplied at the end. Yes, you're right. Exactly. Yeah.
Okay, cool. Thank you.
So this is the right comment. This formula can be also shown as this A, B. Oh, well, I cannot write it down. So A1, A2, A3, B1, B2, B3, C1, C2, C3. Yeah, correct. That's very clever that you remember that. Pretty cool. So remember, ABC is the vector. We did that. Okay, very productive. This is the projection. I already talked about it, but see, I told you like how much B makes the shade on top of the A. Let's check. Yeah, A times A did not have a square. It's either square or just A times A. You don't do both. So A times A is A squared. That's what I meant. But then I accidentally did the other one. Anyway, here's the formula. You need to know those two formulas, unfortunately. Here's some examples how to calculate them. Here's the analogy. So projection of B onto A. B hugs A. because it wants to become A. So that's kind of like, you see, it's want to fall down and hug A because it's really misses it. B is blue, hugging A. A is red. So B hugs A at the top to become, so that's how you get B times A, because it's hugs. Then A becomes happy and it hugs itself. And like, oh, and then at the end, you multiply by A. There's no cute phrase about that. You just need to remember to multiply by A. That's what he told me. I kind of thought it was cute. Okay, we did that. We did just scalar projection. I call scalar projection the component of the projection. I know this notation, but it's not very popular. Skip that. Vector projection, scalar projection. Ta-da-da-da-da. Okay, very good. That is not enough. So we're gonna go to this one. Keep going. Let me see. No, it's okay. I think I had one more here. After that, we are going to lines. Yes, here they are. I was surprised. Where are the lines? Okay, good. So let me check my notes. 3 points. Oh, do you know, before we go to lines, if you have, if 3 points given, find vector perpendicular to, find a normal vector. Let me actually just see what I did, a screenshot of your homework problem. That's better. Oh yeah, how about this? Before we go to this problem, I want to the next topic of finds. One more example. I like to do one. So find 2, like why there are 2? You'll see 2 unit vectors. Okay, so they don't care about the size of them. They want to be unit. Orthogonal, which is perpendicular, right? Orthogonal to the given vectors and 2. And I have A, 3, -3, and -5. And B, 4, 4, -2. Okay, too many lines. Not enough lines. Okay, good. So what do you do? Okay, if I see orthogonal, well, that's a cross product, right? And then I see normal, and then I see unit. So like, okay, probably 2 steps I need to do is to find cross product and then divide by their size. And guess what? That's the correct answer. So, solution. Step 1. Let's find cross A and B. And you repeat the whole process we just did. So I'm going to skip that. You practice the process and compare the answer. It should be 26 minus 1424 or 26i minus 14j plus 24k. Then step 2, they want it to be unit. So they don't care about the length. We need to get rid of the lengths. But to get rid of the lengths, I need to find the lengths first. The magnitude of this cross product will be a square root 26 squared plus 14 squared plus 24 squared. I always ignore the negative sign because it's squared anyways. It gives you a square root of 1448. And you find the answer. Unit, usually it's U, vector is vector without its size. Well, the size is 1. That's how it's easy to remember. So it's going to be, you just distribute this square root everywhere. It's going to be 26 over the square root minus 14 over the square root, 24 over the square root. That's the vector. So that's the answer. But then they say find 2 vectors. So what is missing then? Something is missing. this visualization will help you. So there's a vector A, and there's a vector B, and they like find two orthogonal vectors. So we found this one, but there's one more. There's this one. So we know we found U, but there's also minus U. So do you know what the two answers will be? Plus and minus, plus, minus, plus and minus. So it's not very hard. Visualization, I think, helps to understand how to find the second one. So that's a good example. I like that. Also practicing cross product, but also understanding that too. Okay, we did this. Equation of the plane. Let's do that. Let's go there. Let me check notes. Order direction, negative. Good job. So here's the idea. We're talking about lines, equation of lines. We used to have the classical equation, right? Y equals mx plus b. Like we were trained on this equation for years. And now we're just making it a little bit more important. Now we have directions and stuff. So let's see what's happening. The line will be described by a vector. That's why it's so unusual. So there's a directional vector, or direction vector, that points at the line and keeps scrolling through the line. So a direction vector is like a slope. It tells you in which direction a line is going. So you see we had y equals 3x plus 2, like a classical thing. But now how are we going to describe 0 to what it has to do to that? 1 and 3. I just like to go to the formula right away. I feel like too much is overcomplicating it. The formula is, there are two ways of writing it down. The vector form, actually there are three, no, there are two ways. Vector form, I would say actually three ways. Vector form in the vector form in the form of one vector plus another vector, and component form of system of the components. Okay, let's do it. Find parametric equation of the line going through the given point with the given direction vector. So what is happening here? We have the line, it already exists. And then we know it's going through the point. The point is 1, 2, 3, 1, 2, 3. That doesn't fix a unique line. This can be this line or this line and this line. That's what the direction matters. The direction is slope. So that m we used to have, remember y equals mx plus b. M is a slope. It tells you how steep the line is. So this line, if you imagine it's a hike, right? You're hiking here. Is it steep? If it's very steep, it will be vertical. You have to learn how to do rock climbing. If it's completely flat, that's a floor in the classroom. That's 0 steep. So steepness is directed by m. But now in the vector form, directional vector tells you the steepness, and that's why it's included into the formula. The moment this direction is showing up, that fixes a unique line. So you just need to know the formula. The formula will be x equals y equals z equals. I will start with this form because it's the most close one to the one we knew before. Remember the mx, y equals mx plus b shape? Well, now it's going to be for each component, x, y, z. So we have slope, but the slope now has 3 components, 4, 5, and 6. So it's going to be a 4, 5, and 6. Components are always multiplied, those slopes are multiplied by a variable. It used to be x, but now we're increasing dimensions, so we're going to use parameterization t. So t, t, t. Let me put it down below. T. Those are slopes. Slopes are coming from the slope vector, direction vector. And then remember mx plus b, the b is coming from the given point. So it's going to be plus, plus, plus. And the point is 1, 2, 3, 1, 2, 3. 1 was corresponding to the x, 2 was corresponding to y, z was corresponding to 3. So now it makes sense. So v is 4, 5, 6. That is your direction vector. And it's like a slope, basically. This, I'm going to make it yellow. This is a slope. And 1, 2, 3 is a point. You can also write it down in this form, like so. Let me make it a bit clear. I would say those are more classical forms. The last form is the one you like the most because people got used to it. It is component of x, comma, component of y, component of z. Remember, this is x equals, y equals, z equals. X equals, comma, R is x, y, z. So the last form is you just copy paste x, y, z. But then the second one is interesting. If you write it down, actually, if you write it down as a point separately, but again, it's not a point with parentheses, it's a vector 1, 2, 3, pointing at the point 1, 2, 3. Plus the slope, and the slope comes from a direction vector, multiplied by t. So it is still b plus mx form. You see, b is the fixed stuff, mx is a slope times the variable. We're just kind of increasing dimensions here and also going to vector calculus. That's why it's so unusual. Is this confusing? Let me also rewrite this. X equals y equals. This is going to be very important for the whole class, that this x, y, and z are written in the list. Okay, no questions. That is the idea. You need to be very comfortable with that. So find the parametric equation of the line if we give you a point and another point. So a line can be written or found via two things, a point and direction. A point and direction, remember that. Point and where is it going, the slope. That's how you have it. So we have a point A and B. You can choose one anyway, it doesn't matter. What we don't have is direction. To create direction, you find AB, and that's how or BA, and that's how you find the equation of the line. Just be consistent. If you found AB, use A as the point. So here, the point was given, and the direction is coming from that point. So same here, if you choose A to be that point, just to start with AB, create AB, and then write down the answer. Those are the forms we have. Actually, it's not 3 forms. The form number 1. So here's my vector AB. As always, we do last minus first. 1 minus 5 and 4. This is my slope, if you want to see it this way, my slope. Since this is my slope, I now know how the equation of the line will look like in all 3 notations. The one is the unusual one, is slope is 1, so it's going to be 1t plus a point. A point, let's choose A, 2, 4 minus 3, so plus 2, comma. Minus 5 is a slope, plus a point 4, here it is, 4, comma. 4t, you don't see the sign, minus 3. So slope and point, or you can do point and slope, doesn't matter, you choose. Then this is x, this is y, this is z, so you can write it down as a system. That's the least popular. And you can also write down it as a separate stuff. I saw it on the test to make sure you understand. This is your slope, whatever is attached to a variable is always a slope. That's why it's called the rate. It's attached to the rate, it's changing. And then whatever is not changing, it's fixed. So what is fixed? The point. So this is one more way to see it. So basically my question is, I would say like, this what bothers me a little bit. Do you know how to rewrite? R is given as 0, 1, 5 plus 1, 2, 3 t. Do you know what that means? Can you rewrite it in the form? Do you understand what is what here? The whatever is attached to t is your slope. Whatever is standing by itself is the point. Even though it's not parentheses, it's the vector pointing at the point. So on the graph, it was here. If this is a point, there's a vector pointing at that point. That's what it means. So you can rewrite it as 0 plus 1t, 1 plus 2t, 5 plus 3t. And from here, you can rewrite it as x, y, and z. Here's your three forms all in once. Make sense? So make sure you can work with any given form, because I've seen all three. I'm afraid you will be confused. Okay, this is good. Now, okay, how about these parallel lines, skew lines? I mean, I did not give any skew lines on the test.
Sorry, can I ask you a question?
Mm-hmm.
So we could take the test on Thursday night, right?
Can you say it again?
So we could take the test until Thursday night, right?
Oh, yes. I decided to keep it open till Thursday night. Just don't postpone till the last moment, because that's already extension. So if you ask extension for the extension, I will say no.
Okay. And it's 12 questions, right? How many multiple choice and how many free response?
Yeah, I will not tell you that, but I did
Oh, okay.
mention the post 12 questions, all from homework. And I will post more information about the test proctoring system right after the review. And you
Okay.
have a practice exam now to see how it works.
All right. Thank you.
Good, thank you for the good question. So parallel stuff, not parallel stuff. Interesting, we knew parallel intersection, but now we have skew, which is pretty cool because they are not parallel, not intersecting, because it's in 3D. So it's like a kebab, one here, one here. They don't touch each other, but they're not parallel either. I think I have a tasty picture somewhere at the end, but whatever. So the most important is how to figure out what does it mean. Here's the lines. Do they intersect? What is happening here? So let's do one like that. Plane. Oh, that's already about the planes. Yeah, that's very good. So let's move to the planes and check the parallelity and perpendicularity. The plane equation. This was just recent. I saw people were stuck with that. Planes. There are several ways of showing them. The original way is this one, the second one over this one. I like this one more because remember there's equation of the line was y minus y0 equals mx minus x0. That's one of the equation of the line, right? So again, slope multiplied by change of input equals change of output. X is input, y is output. Domain range. So we're just increasing the whole idea to the next dimension. A, so that's my slope, times x minus x0. B, C, isn't cool. So A, B, C, which like was not smart to use black color to circle them. A, B, C are just like before my slopes. Each of them tell me how to tilt, how much to tilt towards each direction. So my slopes are coming, well, in this case, they are normal slopes, so the sticking out ones. The confusing part is what it has to do to the tangent slopes and stuff. When you tilt in, the plane tilts too. So the plane can be fixed by having a point. Point isn't enough because there's like thousands of different planes going through that point. But the moment you fix the normal sticking out vector, it fixes the tiltness of the plane. So that's why A, B, C are coming from the normal vector. So, and then the point, that is a shift, right? So the point, here it is. And the end sticking out thing equals to 0. Then when you simplify all of those things, distribute them, collect the points, then you simplify, it gives you this 8x by cz equals d or plus d, doesn't matter. So this d shows up. I like the second one, then from second one, you have a first one. And on the test, they will ask you both, so make sure you do both. Normal is a perpendicular, so we know that. And we even know where it's coming from. We can find cross product of some two vectors, like this one and like this one, like so. A and B gives you n sticking out from the piece of paper, perpendicular vector. So you see, those are like slopes, but they are sticking out slopes. So n perpendicular ones. Find the equation of plane going through with a normal vector. So you just write it down. This is literally already give you the equation. That's not a good exam problem because it's going to be too easy. Let me do it with you. So you just need to know what to plug into the equation. I remember it's x minus point, y minus point, z minus point. So point is 1, 2, 3. And then this should be normal. Either you need to find or they gave it to you. 4, 5, 6 equals to 0. Simplify and you get a simplified version if they ask you to. And usually they do ask you for that. So how about this one? And there were so many homework questions on the plane chapter. Can you like work? Thank you. Oh, I see. Example. Probably should put 1. No, that's 4. 4. One more example. Can you find EQN? That's one notation for equation. Some people in the forum said they keep watching my videos. Now they know all my notation for calculus 1, 2, and 3. That's so funny. Equation. If you watch my videos, you will see lots of funny jokes there. I always teach with some kind of jokes. I think there was a study shown that sense of humor helps students to remember formulas better. That's why students who watch my videos, they know I have jokes about some formulas. That makes it funny, but also some kind of like the brain connects it to the long-term memory versus short-term memory for the formula. So we're going through the point. Oh, at least the point is given. Yay. And then they say, which is parallel to the plane. So equation of the plane and parallel, that's one notation for parallel, to the plane to, oh, let's not do that. And let's do it fine. 2y minus 3x minus 4z equals to 2. So that's from your homework. So I know the equation. It's just like, it feels weird. Something is not right, yeah? So let's see. The equation says, just like at the top, I have a point. So it's going to be x minus 4, y minus 0, z minus 3, right? I have that. Then what should I put here? They did not give me n, and they told me that it's going to be parallel to some other plane. Well, parallel planes have the same normal vectors. That's what you need to understand. Let's visualize that. Plane you're looking for, plane they gave you. They're parallel. One sticking out vector, normal vector, well, it should be parallel to that one. Thus, we can use these numbers what numbers? We can use, let me illustrate, these 4, 5, 6, but for the new plane to use in my plane. So I will use 2, minus 3, and 4, right? And then I noticed that they made such a mean thing. You see, it's not ordered. I was like, that's so mean. So keep an eye on the test. It should be minus 3x plus 2y minus 4z. Like, who decided that was okay to be so mean? I don't know. So we're gonna use minus 3, 2, and minus 4. And that is the answer. Minus 3, 2, and minus 4 slopes, which came from normal vector of another plane, but they are parallel, so normal vectors are also parallel, right? And we have a point. And then they told you, we don't like this answer, you need to simplify. You're like, oh, fine, whatever. Minus 3x plus 2y minus 4z equals, so that was easy. And then you need to collect actually the numbers. Minus 12, minus 12. Oh, that was easy. Minus 12 and minus 12. So it's going to be minus 24, right? But then if they wanted to write down equal, you put equal to it. What do you think about that? So let me see, there's some questions. So can we take the test on Thursday night? Yes, just don't postpone. Then I was wondering during a question about finding the equation of the plane with a point and the line that plane contains. How to calculate that? Is the contained line just normal? Let me try to understand what's the question. So the equation of the plane with a point and the line that contains, the line that plane contains. No, plane contains the line means line lies on the plane. So it's not the normal. You need to find cross product. Yeah, like Giovanni said. Yeah, I know, I recognize the question. So the question is if it has a line containing it. The plane contains the line. That literally means that the line is on this thing. That is not enough. You need to find the orthogonal vector to figure out the equation of the plane using the plane that is right there. Yeah. And there's a question also. See. On the practice thing, there was a problem. We need to match the graph with the equation. You definitely should expect some graphs. I don't like putting them on a test, but they told me that there should be graphs for the online class. For the in-person class, we usually don't do it. For the online class, because we're copying it from homework exactly, then yeah, they just put some graphs there, and sometimes you need to match stuff, unfortunately. So definitely review that. Good questions.
Sorry, can you repeat what you said about the graphs?
For the graphs, they were like homework questions when there were some different equations, the plane, or some other stuff, and then there were graphs. Yeah, you must, basically we take your homework problems for the exam, so you can expect them there.
Okay.
Those are my least favorite one. It's time consuming, but I do see that they put it there for some exams.
And also we can attempt the multiple choice questions twice, right?
Basically, yeah, it tells you what is right, what is wrong. Yeah.
Yeah, so if it's wrong, we could try one more time, right?
Yes, yes. And that's why I don't see lots of multiple choice there.
Okay.
Yeah, exactly.
Thank you.
Thank you. So these questions, if you have 3 points, you know what to do, right? You must know this problem. We also like to put it on the final exam. You have 3 points. What to do, how to figure out the plane. Choose any to create basically choose the starting point. Let's do that. From there, create 2 vectors. From there, that's your A and that's your B. From there, find the cross product. That is your N. And now you know what to do. from there, you just have a definition. And comes, in this case, in blue, slopes 9 minus 21 and 48. That's your n. And then choose the point, any point out of 3 actually will work. And voila, you got the equation. So that is the most classic problem to give on a test, just like that, you know. Okay, there's lots of questions suddenly. Just let's see. Let's see. Oh, the questions about the space curves and stuff, post them in the forum and I will check. I can answer in the forum. If in general, we usually say that everything should be expected. But 10.6 in online class is extra credit. No, it's not going to the exam, I mean, and it's extra credit for homework. This class is too short, so we tend to skip it. I actually like to skip too much stuff already. For you guys. So 3 points, we did that. Line intersects the plane. Let me see that. So I wanted to show you parallel we did. Containing 3 points we did. Parallel, orthogonal, or neither or neither, right? Review that. Those like those funny things. How to know if planes, example, planes are parallel, orthogonal, or neither. How do you know? So from your homework, you had 5x plus 2y minus 5z equals 2. That's a given one. Given. So A, let's compare it to 15x plus 6y minus 15z equals to 4. Yes, no, which one do you think? So you check the normal vectors. If the plane is parallel to another plane, then these guys will be parallel, the ends, right? But what does it mean for vectors to be parallel? They are scalar, what do I want to say? They are scalar multiples of each other. So let's check. N1, that's like the first, the given one, is 5, 2 minus 5. 5, 2 minus 5. Okay. And 2 is 15, 6 minus 15. Yay! They are scalar multiples. Scalar multiples. So answer, these are parallel, 2 parallel planes. Because just the one vector is like bigger than another one, but they're still parallel, right? Now, how about this one? B. Minus 2x plus 5y equals to 1. Yeah, they don't have any connection. I didn't see that, but I can check the dot products and see if it's, so of course you can check n1 times n1, or, that's my or, n1 times n2. Which one do you want, scalar product or dot product? If dot product gives you 0, they are perpendicular. If cross product gives you 0, they are parallel. You can do that. But one is just longer. So usually people do the dot product, right? Let's check the dot product. It's faster. Then it's going to be 5, 2 minus 5, that's the original one, dot product with minus 2, 5, and 0 is this missing one, equals, yay, it is 0. So perpendicular, answer, perpendicular. That is because if one n, let's do it, one n is perpendicular to another n, then the plane of the first, of the second one is perpendicular of the plane of the first, and so on. And then if you cannot find any of these, then probably It's neither orthogonal nor parallel. Do you remember the distance formula? This thing, find a distance between the point and the plane. You need to know this formula. It's might be on the test. So the formula is you divide by the classical square root of a squared plus b squared plus c squared. And then the top one is absolute value of the equation you have with that point plugged in. So let's see, let's practice. If the point, oh, here's the example, 1, 2, 3, the point 1, 2, 3, the equation is 4x, 5y, 6z. So what is my d if it's equals to d? D is 0, right? So make sure you understand that. Then it will be not d. Now I should not confuse that. There's a capital D and small d. I mean, and the thing is, like around the world, they did not agree to put a capital T or a small t. I mean the formula ax1 plus by. I don't like this either. Ax plus by plus cz equals to d, this one. So if it's 0, then d is 0. But capital D is a distance. The square root is the easy one. The square root of ABC, not the point, which makes sense, but the normal. So, you know, distance have something to do with the normal vector, right? You see the distance is perpendicular. Like, what is the shortest way to go to from your work to home? The most short one will be the not diagonal one, not some kind of like this, just go home. Don't go to the bar and you don't go to the store, just go home right away. That's perpendicularity, basically. So you're using this 4, 5, 6. 4 squared plus 5 squared plus 6 squared at the denominator. And now at the top, you have ax plus by plus cz plus d, where you plug the point. That's the cool part of it. So it will be 4x plus 5y plus 6z, and then plus d, don't forget the d thing, plus 0. But you plug your x, y, z as 1, 2, 3. And then you don't want a negative distance. The square root is not going to give you negative. That's good. But the numerator might give you negative. And I don't want to have negative 7.3 as a distance. Distance is like how far your house is from work. So I take absolute value to get a specific number. And I get a specific number. 4 plus 10 plus whatever. Anyway, check mark. So make sure you remember that normal goes to the denominator as a distance, and the top gives you the location of the point. You basically plug this point into the plane to locate it, be kind of like this is how I see it. You know, if you plug the point into the plane, it becomes over here, right? Plug. So the point gets plugged into the equation of the plane. Now it's on the plane literally. And then the normal, when you take a normal vector, it gives you this distance. That's kind of how I visualize it, why the formula was created this way. But you can also find and check how the formula was derived. Maybe it will help you to remember. Okay, we just had two perpendicular planes. This is how they look. Again, pretty cool that the green plane has this green normal vector sticking out. The blue plane has this blue normal vector sticking out. The perpendicular, so those two vectors, perpendicular, blah, blah, blah. Finding the last two chapters. Let me check on more stuff. The parametric forms of the point. There's still some things I wanted to show you. The last two chapters were about this. Yeah, that's actually good. The vector valued function, or the vector function, is the function which has a domain. Domain means it takes in some stuff, swallows the stuff, real numbers, but spits out vectors. How cool is that? So well, we show that any kind of function is a machine, like x squared. You drop in some numbers and it takes out numbers. So domain and range. Swallow spits out, right? But in this case, it's a vector function, say r of t. And it's pretty cool that it takes in numbers, right? Numbers. And then does something in this machine, vector machine, function machine, and gives you vectors. How cool is that? So at the number 5, you get a vector 3719 with like a distance, with a direction and size. It's pretty cool. Component function of the function and so on. So it took you back to calculus 1. Find the limit of stuff, find the integral, find the derivative. I hope you remember that. Because to be honest, they're supposed to be the easiest questions in the exam, unless you don't remember chain rule. So I can review right now for you. But that's why I was sending you announcements before the class started to review chain rule and product rule, because I know they were coming. Yeah, this is the question I want to show. But first, let's just practice derivatives and chain rule. Check it out. So write down the example. Find second derivative where r is e to the t, e to the 2t, e to the 4t. R is a vector function. It has numbers as input. So e to the t, so it's a number. It's some kind of t, say like t is 0, e to the t is 1. So it's a number. But the moment you plug all those numbers in with t0, for example, or t1 or pi, the output is a vector. For each different number, you have different vectors. So it's a vector function. Derivative of e to the t is e to the t. Derivative of e to the 2t is e to the 2t times, chain rule says, take the derivative of the function inside. That 2t gives you 2 when you differentiate it. Same with 4t. E to the 4t times derivative of the exponent, which is 4. And then you repeat the process for the second derivative. So integration, repeat integration. Integral or E4t. This requires U substitution, but if you watch my videos of shortcut of U substitution, it tells you you copy and you divide by the leading coefficient. That's what is happening. And leading coefficient of the exponent, so 4. That's basically undoing chain rule. That is the idea. U substitution undoes chain rule. So review some integration, power rules, limits, and so on. That is not supposed to be the hard part, but if you don't remember that, that's going to be upsetting. So we also gave you this idea of the unit tension vector. Don't be scared of it. You take the derivative and you get rid of its size. That is the idea. So derivative gives you tangent vector. That makes sense because derivative and tangent always had a connection. Check it out. So there's a curve, right? Here's the curve. So the bicyclist, for example, is racing on this curve like so. And you want to see the slope, how steep for the bicycle it was to turn. Like did the bicyclist almost failed or it was fine? That means at this point, I want to find the steepness, the slope. So I find derivative, here it is. And before in calculus 1, is the derivative or tangent just did not have any direction. Well, now it has. That's the only difference. That's why it's r prime, not it was slope m, right? It was like f prime, but now it has a direction. So it's all about vectors now at the point A. So it gives me the slope. The bigger the slope, the harder it is for the bicyclist to turn and so on. So the sharper it is. Well, sometimes it's the other way around, actually. There's a whole mathematical study about highways and how dangerous it is to turn if you don't have good vision. So they calculated all the slopes to have highways safer when they turn left or right, because if there's a truck and you are driving here, you might not notice the truck, and then you need to be more careful and so on. So there's like a whole study about that. Pretty cool, actually. Concavity and second derivative. But this unit tangent vector doesn't want to have the size of the slope. You see, this is how big r is. It has some kind of size. Well, what if I don't want to know the size? It's like extra information, which is quite important many times. You just need to know where is it pointing. So that's t. T takes the slope and gets rid of its size. So that's a unit tangent vector. There's nothing new here. It's like this is something we had before. So r prime is a slope, but now it just also has a direction. So it's directional slope, basically. Vector, it's a vector of the tangent line to the curve at the given point. Find the equation of a tangent line to the curve at t equals 1. I don't know if we have time. I just wanted to show something first, what I want. Review that. I want to review more the notation. The tangent line, find the equation of a tangent line. So this is new notation. Point, so the line can be written as, oh, it's not new, actually. I already explained before. It just looks different now. So r can be written as x, comma, y, comma, z, comma. Or if you remember, we had this pointing vector to the point times the slope. And the slope always multiplied by t. So point directional vector, that gives you a line. What else can define the line? We need a point and the slope vector. Here is my unit vector, we have that. Find it, plug 0. So that is what I wanted to practice. This here. Over here. Here it is. Example. Find a vector equation. EQN, that's the equation. R of t, let's see. R of t for the line. Oh, I see. I wanted to practice this because it's the new notation stuff. Find the vector equation R of t for the line that's going through 2 points, P minus 3 minus 5 minus 3. That's from your homework. And Q, also all your homework solutions right now are open. Minus 4, minus 10, and 2. For each of the given conditions. For given T. So A. If R at 0, that's a vector, gives you minus 3, minus 5, minus 3, and R at 7 gives you a vector minus 4, minus 10, and 2. Then let's find R of t. Well, that's where it was at the very beginning. Solution. So we have a point P. We can use that point as a base point, right? So for example, we choose point P to, I want to use another color. We choose the point P to be our base point. So for example, choose P. Then I know that the equation of the line, find the parametric equation of the line will be like so. It has a point minus 3, minus 5, minus 3. I chose that point P. And now I will have the slope times t, right? So we always have this idea. mx plus b, that's how still I remember that. mx plus b, like we have this from the previous materials. Okay, so the point is already here. What is happening with the slope? Well, we have two conditions. So if we plug 0, we get -3, -5, -3. But at 7, we have -4, -10, and 2. What do you think we should do here? Yeah, let me check the chat. What do you guys think we should do? Can you think in the chat about this problem? What do you think we should write down for the slope? How did we get any information from plugging 7 and getting -4, -10, and 2? What do you think? So we have, so someone shows me t minus 7 over 7 minus 0. This is a cool way to explain it, but we need to explain more details. T minus 7 over 7 minus 0. What does it mean? T minus 7 over 7 minus 0. I remember many students stuck on this problem, so I wanted to show that. How did you get that? We have the beginning and the end, 0 and 7. Remember that 0 and 7, that's t. T is 0, t is 7. That's why it says that for given t, right? So remember the formula. We have like lots of formulas of rate, y mod 2 minus y1, x2 minus x1, that kind of stuff. So next one minus previous one. Next one minus previous one. Input always goes at the bottom. Inputs are 0 and 7. So I will have 7 minus 0. And then the new one, people are still asking questions. And the new one is t minus 7. So the shift is happening by 7 units. That means does anyone know? Does anyone know? T divided by 7. That's how we get from the denominator. And what should I multiply by over here? Do you know? Let me answer about the partial credit in a second. PQ. So we need to find the direction, because if you remember, exactly, thank you for posting. If you remember, we need direction and the point. We chose the point. Let's find the PQ. PQ is next minus previous one, next minus previous one, blah, blah, blah. So -4 and +3 is -1. And -10 and +5 is -5. And then 2 plus 3 is 5. So that is what we're having here. -1, -5, and 5. Oh. So these kind of things are super annoying, and you just practice this because unfortunately you might have them. Those are also from homework though. Let me check also. So there was a question in the chat about partial credit. In online classes, what we do, we don't give you partial credit for the written part. You just submit written part for the record. But what I do, I spend lots of time going through your exams. That takes like 2 days or more because I have 250 students taking this exam right now, tomorrow. And I look if you did a typo, mistake, some minus, negative sign, you lost a decimal, you put like e squared like this. Sometimes that's like a mistake, right? Instead of e squared. Then I give you partial credit or sometimes even full credit. So that takes forever, but it's worth it. I always do that. Let me check. TF2 RTT. Actually, it's pretty good. I think we covered everything I wanted to cover. Oh, and the last chapters were about the sphere. Let me see the questions. Thank you. Oh. Yeah. Oh, that's a type. I copied your type, you see. That's not smart. T minus 0, 7 minus 0. Exactly. That's why I know that there should be nothing here. So the spheres, the very last topics were about the spheres. Just make sure you know the equation of the sphere. There is it's not very bad. I don't like the words equidistance. So if you ever hated that word, don't worry. I don't like putting it on the test. I'm talking about equidistance. You will have it a lot in the engineering and physics. So I don't put it in our classes. Not too complicated. It's not too complicated, but I don't like the English part of it. So I'm caring about students who are English as a second language students, ESL students. So let's not scare people when we just needed to do math. That's really hard work over there. Word over there. Sphere, you just remember the formula and make sure we give you a point and R, and you know how to create the equation of the sphere. So that was one of the last topics we covered. Oh, the physics questions are my least favorite, but actually there's a question in the chat about the physics problems. Because this class is for engineers, engineering department stepped in and told us to put more, more applied physics questions to the exams, which is not my favorite at all. So every time you see a very annoying physics question, you know whom to blame. That's the engineering department. Actually, I'm not making this up. There was a meeting. They even gave us some kind of percentage, 33% to have physics problems, but we ditched the percentage, which is to like very, whatever we do, I don't know. So just for you to know, you know who'll be angry. Let's see. The stone, the some come down. So the pushing stuff, definitely review that. I don't want to stay longer than 2 hours. So usually my voice is dropping anyways, but I can tell you what to review from physics. Definitely review the FMA, which takes us actually right now to the first, second derivatives, right? You guys should feel comfortable finding velocity. Let me put it at the very end. Oh, it's fine. So velocity V is your R prime, right? Those are my favorite problems because they're very simple. You just find the first derivative, acceleration, A, that is second derivative of the R or V prime. So you find that. And then sometimes they ask you, will find the size of velocity. Well, you know what it means. That's a magnitude of V, or size of A. That's the magnitude of A. You know how to do that. Then the force. So review the problems with the force. Review the problems with the throwing things, and it hits some kind of maximum point, They like those problems a lot. The objects going up and down. I have videos on those, as I remember. Or if you want me, I can make some. What else? Let me check. Chat. Do you know if there were physics questions on the test? Yeah, that's kind of the answer. Unfortunately, they are. So that is good. Any questions you stuck? So let me again show you that you have practice exam that shows you how to do 2 correct or incorrect 2 attempts. But if you stuck, definitely post questions in the forum. And I also wanted to show you the modules. I post lots of cool information here. So this is the files I'm using for my reviews. Those are all the reviews I have. Actually, I already opened it here, called exam reviews. So this video, which is hopefully recording, because actually I never heard a phrase saying it's recording. I will be posting it here when it's going to be created. All the reviews are here, so it's very nice. Always choose the longest one, and they're always the best. Now, I have test files, check them out. There's like a whole file. I collected loads of stuff. I put hours in this. My students put hours in this, my previous students. So we have stuff. Then the notes from this review, I will post it here. This is the old one. So I will update these notes. And that took me weeks of work. Did you see the practice exam? This one is mostly targeting the in-person class, not the online one, but it still has lots of questions that you will see on the test. Like you see, look at the sphere question. It's already there right away. Here it is. So you can practice. It has infinitely many attempts. It's not for grade. That's just for fun. See, what is the following point closest to the YZ plane and so on. That's about the distance, basically. We have free response questions in in-person classes. So find the velocity and position, right? And what is the equation of the line through the points? Look at this. That took me weeks of work. So I have all the practice exam 1, 2, and 3, and the final. But for you guys, exam 3 is the final. See, what is the vector? The same direction as 1 to 2, but length 6. How do you do that? You find unit vector and multiply by 6. And so on. So practice these. And then whatever you stuck, you just gonna post in the forum. The good question in the forum is where do we put our written work? It's actually over here. If you go to assignments, then it's here. Exam 1, submit your sketch paper here after the test. So right away, make photos and submit them over here in assignments. I can also put it in modules so that you can find it faster, but it's going to be the same thing. It's a file upload. Thank you for asking. Okay, people. Yeah, post questions in the forum because I'm checking it and my helpers keep checking it actively. Thank you for coming. Is the written practice problems in the exam 1 module more correctly match up with what we're seeing? Written practice. All of them. No, they all good. But again, I should tell you that I should tell you that we just take it from your homework, so that's what you should concentrate. Your homework is the one that you should know that there's no trick. There's no trick here. It's coming from the homework. So you just practice all these. For example, 10.5. And you see all of these problems, just take them out, some of them randomly, some of them not. See, check it out. Yeah, I think we already worked on this problem through the review and we put it, and now you have all the solutions. I just posted them. Is the force a vector? Yes, the force is the vector. Oh, thank you, Jeleni answered. It has, so how strong you're pushing I'm pushing a chair away from the table. How strong I'm pushing, that's going to be a size of the vector, that's magnitude. But then where am I pushing? To the left, right? So that's a direction. Direction and size, that's a vector. So the question is in the forum, can we regenerate problems in the homework? The thing is, I did put the check mark for that and it did not work. Let me try again, but I went to settings and I actually did check mark there that you should have several homework problems, several different ones. And then I asked in the forum and people don't see it. So either they just deleted this option at all, or I can try again and see if it works. Because I like that option too, that you can have several regenerated problems. Yeah, I also think that it's useful. That's how you practice, like you have the repetition. I totally agree with you. So let me check it again and see if it works. Maybe it's a free program, so they told us not to complain, but yeah. 10.6 is not in the test. Yes, please read carefully my announcement, because lots of details there are pretty important, and including what chapters are not covered. So you skip 10.6, it says here. And then you just have all my notes here, everything, how to practice and take the test, preferably tomorrow. Don't forget, don't open anything on any site. We see everything and you'll be watched by other people during the test anyways. Check the school problem. You can have this on exam 3. Triple integrals are pretty cool. Okay, thank you for coming. Good job for asking good questions. Practice a lot, and I will hopefully be sending you all the videos and notes in 2 hours. It takes 2 hours to create a 2 hours video. Thank you. You're doing an amazing job, working very hard. I saw the progress of homework. It was amazing. And the forum is super active. Have a good night.